Our next talk is on a related topic. It's also on, the title is Partial Offload Optimization and Performance on Intel Fortville NICs using RTE Flow. And we have a substitute speaker here. Our speaker is Masood. Please.
Thank you, Ben. Good afternoon. Careful attendees might tell I'm not Irene. I'm also not Chenmin, but I'm going to try my best to cover for them. So all the credit should go to these folks. They've done a great job. And if I screw up, that's me. So this is great lineup. So you guys are warmed up to RT Flow, and I'm just going to talk about the optimizations that were related to some of our NICs that might be present in some server that you might be using. So the hardware offload feature, as it stands in OVS today, was first available about a year ago. So it's called this, hardware offload thing. It's a global flag. You just turn it on and hope it works, at least so far. And it does support so-called the partial offloading. So partial offloading in this context means you get some assistance from the NIC hardware to get some acceleration going, but it doesn't do all the job for you. So you still use the software data plane to complete the processing of switching. So, but it does allow OVS, even in the partial sense, avoid some of the costlier operations, which include the miniflow extraction, EMC, lookup, and portions of the DPCLS lookup. It really depends on the context, but it does support certain protocols. So if you're using a very complex chain of, virtual networking, it may or may not be really accelerating, but for most of the basic, chains of protocols, it should be able to get you going. And then on the right side, most people might be familiar with the processing and then the fast path that is related to the first level of caching like EMC or SMC. And then the hardware offload and the partial offload in this context is giving you a faster than the fast plate, which is basically whenever you see a flow identified in DPCLS, you go back and ask your hardware to, hey, why don't you mark these packets for me in the future so I could actually do a direct lookup through a cache, hash map. So, and then this would be your fast path or faster path. Sorry, I'm just going to. Okay, let me see if I can come back enough. All right. Nope. All right. So on the right side are some of the devices that will be relevant to this, the updates I will give in this talk. So it is, Intel's 700 series adapters. So these happen to be in the form of 1 gig, 10 gig, 25 or 40 gig adapters that you might find in servers. So, and then it did support RT flow pretty much since its inception. It supports certain actions. So some of the items you heard in the previous talk were supported from this driver. And then it does allow about 8,000 rules in the device memory itself. And what's happened in DPDK 1908 is we did add support for marking and doing RSS on the flows at the same time through RT flow. And that basically opened up the stage for partial offload of OVS to work with our devices. And then more recently, DPDK 1911 added this support for vector receive path, which turns out to be the default path when you use any of the modern hardware, because DPDK, as Harry covered earlier, and he's, by the way, the resident vector bender here. So if you have hard questions about this, so he's also somewhat affiliated with this, which means he did all the hard work. So if you want to use it, you can just go ahead and use DPDK next branch with DPDK 1911, which is out there, and then you could actually start enjoying some partial offload. And I'm going to just show you some results for from the experiments we just did using this 1911 release. So basically, I'll just cover two sets of experiments. On the left side is a Phy-Phy test, which basically takes packets in from a physical port, just puts them out with some processing. And then the second one, there's actually a VM involved, so we do this thing called Phy-Phy test. And then we try different package sizes, different protocols. And so a bit of an eye chart here, but I'm just going to cover three things. I want to tell you first, the offloads. So first of all, the geometry of these graphs there are these quadruples for each packet size. And the first two are basically 1 million flows, and then with and without offload, and then 10 million flows with and without offload. And these are the flows as they travel in wire. I know that there's some, terminology issue about flows and rules, etc. So here in this context, the flows are, the distinct things that go on the wire. And rules are the things that we basically program into the switch. So on the x-axis, you have 1K, 7K, and 10K rules, just to give you a flavor as to what happens even if the rules don't fit into hardware. So the savings or performance improvements seem to be consistent across different packet sizes, except for maybe when you reach line. I believe these experiments for 1K packet size is reaching the line rate, so you don't see much more than that. So, and then the second one is on, as you increase the number of rules, obviously, if you can't really fit into hardware, some of the flow rules will be basically handled by the software data path. And then the third one is, as you spend your CPU for more of the non-offloadable ports, obviously you basically get a lot less benefit because you have to spend so much time in doing, say, like virtual port management. So we've seen up to 80% in Phy-Phy and 25% savings in the cases of virtual tests. So, and then this is the core scaling test. We just wanted to understand how it looks if we added more cores in order to process these queues that we added. It seems to be consistent. And then let me just go into this and summarize. So basically, performance improvements are there. And then as you add more cores, you will have less benefits, especially if you're adding more than 4 cores per physical port. You have ample CPU cycles. So the CPU cycle savings you get from really the offload acceleration from NIC starts to pale in comparison. But if you're really trying to minimize your infrastructure cycles, this seems to be a good way to go about it. And then, different package sizes gave us, pretty much consistent results. So that's all I have for today. So feel free to ping me after this as well if you have more in-depth questions about this. But thank you for your time.
Thank you.